So I thought we'd go straight into an example because it's best to learn it while actually looking at a problem. So the first one. So find all solutions to sine theta equals 1/2 for theta between 0 and 4 pi inclusive. So what we do is I'm just going to draw out the sine graph because that's what the question's talking about. Technically that should be theta. We go up, down, whoopsie, got to extend it out a bit more. Okay, so go up one more. So that would be pi here, and this would be 2 pi, this would be 3 pi, and this one here is 4 pi. So that's just our ordinary sine graph. That point would be 1, that point would be -1. Okay, so when the question is saying sine theta equals 1/2, what we're actually looking for is what is sine the y or the x value? The y value, yeah. So we're looking for a y value of 1/2, which is here. Y equals 1/2 on the graph. So what we see is that the solutions of sine theta equals 1/2 is where that dashed line crosses our sine graph. So there's a solution here, 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 and here. So there's a total of 4 solutions. And the solutions are the x values at that point. So we're looking for this value here, this value here, this value here, and this value here. So we want to know what all of those are. Right? So what we can do think about normal trig. How do we get theta on its own? Yeah, so we take it over. Becomes inverse sine. Okay, so you've got to think what angle would give me 1/2 when it's sine, so opposite over hypotenuse. So you got to use those triangles, those 2 different triangles that we learnt. So the first one is the pi on 6 and the pi on 3. There's a √3 opposite the pi on 3, a 1 and a 2. And the other one was pi on 4, and it was 1, 1, √2. So which one of those, which angle, is it pi on 3, pi on 6, or pi on 4, gives you 1/2 on its sine opposite over hypotenuse? Yeah, pi on 6, because opposite 1 over hypotenuse 2 is 1/2. Right, so our angle that we're looking for is pi on 6. So theta equals pi on 6. Oh, bless you. Right, so that's our little unit circle. So we know that that angle in there is pi on 6. That gives us 1/2 for our sine. But we know by symmetry that it's also 1/2 over at this point. This quadrant is known as pi minus theta. So if it's pi minus theta and theta is pi on 6, what is the full value? 5 pi on 6. Yeah. Because we've also got pi minus theta, which equals pi minus pi on 6, which equals 6 pi on 6 minus pi on 6, which is 5 pi on 6. So that's another solution. So that would be that one here.
So you have to do it for all 4 quadrants?
Yeah. Not all 4 quadrants. Only the quadrant, like they're not all in all 4, just in the first 2. But we're going from 0 to 4 pi, so we go around twice.
Miss, why couldn't you use pi on 4? Like from the other triangle?
Because we couldn't get 1/2, because that's a root 2.
Yeah.
It only gave us 1 on root 2. Yeah. Yeah, so we've got this one here. We had pi on 6. We went all the way around to this one. We get 5 pi on 6. We're going to go all the way back around. What's that point going to be again? We've got 2 pi plus another pi on 6. Yeah. So we'll have 13 pi on 6. Because 12 would be 2 lots of 6 and then plus another 6. And then go over here. So that would be 1 pi, 2 pi, 3 pi minus pi on 6. So 3 pi is the same as 18 pi on 6. Take 1 pi on 6, 17 pi on 6.
So these are all the values of each point.
Yeah, so that is 13 pi on 6 is this one. 17 pi on 6 would be this one. 5 pi on 6 would be this one. And pi on 6 would be that one. And those are your 4 solutions. Seems tricky. With practice, it becomes really easy.
So we don't go into the bottom 2 quadrants.
Negative 1/2. Yeah. Because you're looking for a y value of 1/2. It's only up here. Yeah. Right, so find all solutions to sine x equals negative 0.3 for x between 0 and 2 pi. So it's just one revolution of the circle this time. Okay, let's draw our unit circle because that'll probably make it easier. Right, we're talking about sine, so it's y value, and we want a y value of negative 0.3. So that would be somewhere down here. Okay, so this quadrant is 2 pi minus x. This quadrant is pi plus x. Remember, if we want to find anything down here, what we do is find the one in the first quadrant and then just use symmetry if it's a positive or a negative. Whoop. So what we're going to do is we're looking for that angle there, and it's going to be the same as this angle in here. So it'd be 0.3 there. Okay. Oh, negative 0.3, sorry. Okay, so what we're going to do is just work out sine of 0.3, because that'll be the first quadrant. So the way we do that, we just take sine over, find the inverse. Right, that one obviously very hard to work out because it's a decimal, so you just use your calculator. This would be a CAS kind of question. So you just like normal inverse sine 0.3.
Is that the radian?
Yes. Yeah, the 0.3 is radians, not degrees. Yeah, so it equals 0.30469. Right, so that's for the first quadrant. That's that point there. Now we're just going to use symmetry to work out the other 2 points. So that's an angle in radians. So we want to work out the angle going the whole way around to here. So we just do pi plus our original angle. So it'd be pi plus 0.30469. And again, that's just a calculator thing. Wouldn't expect you to do that in your head.
So you've only found the first value just so you could work out the other two. So
Yes.
you found the value in...
Yes. Sorry, I shouldn't have written it. It's probably confusing a bit having that x there. Yeah, sorry. It shouldn't be there. Yeah, so what we did was we found this angle first, so we could use that with symmetry to find the whole way around to the other angles. Yeah. Because we're going to find, the black one the whole way around, and then we're going to go from 0 all the way around to that one. Okay, so this is just calculator, so pi as in 3.14159 plus that would give you 3.44629. Yep. Rounded is fine. And then to find the other one, we do 2 pi minus 0.30469. 2 pi is in 2 times 3.14159. So you get 5.97849. You can round 2 decimal places, that's fine. But Right, so for sine x equals negative 0.3, we have, with x being between 0 and 2 pi, so just one full revolution of the circle, we have these two solutions. Okay. Right, so now we're going to solve or find the solutions of sine 2 theta equals negative root 3 on 2 for theta between negative pi and pi inclusive. So essentially what you're trying to get is that angle, whatever it might be, theta, x, t, whatever the symbol is for it, in this case theta, you just want to get that on its own, essentially. So we start off doing some rearranging. So we're going to get rid of the sine first by taking it over the other side. So we get 2 theta equals inverse sine negative root 3 on 2. So we're just going to work it as a positive first because it's a lot easier. And then we're going to do our symmetry thing to get the negative.
You have to divide it by 2.
No, not yet. Wait until the end to do that. Yeah, so essentially what you're going to ask yourself when it's inverse sine is what angle gives me root 3 on 2 when it's sine, opposite over hypotenuse. So you've got to use those triangles. It might be. So we're going to draw our triangle. If you haven't got those memorized yet, I strongly recommend it.
Yeah, it's going to be a long time.
Like as in you're going to struggle in the test if you don't memorize those two triangles. Oh yeah, you can do that. Very good. Okay, so which angle, when it's opposite over hypotenuse, gives us root 3 on 2? James?
The previous triangle had the square 3 on the left. Why is it?
It doesn't matter as long as your root 3 is opposite your pi on 3. I make the 3's opposite. Because it's just as if you were like flipping it over or moving it around. It's the same triangle in the same order. It's just oriented a different way.
So it's based off like pi on 3. That's how you determine the accuracy of the opposite.
It's well, it depends on like what's written here. Basically,
How do you know that's pi on 3?
it's always this. It's always either this triangle or the pi on 4 triangle.
Yeah, but how do you tell if it's like?
If it's opposite over hypotenuse, we know that it is this angle here because opposite root 3 over 2. So we get 2 theta equals pi on 3. Okay, let's consult our unit circle for symmetry.
No. My hair's not
Okay, so this is our y value because it's sine of negative root 3 on 2 across there. So far we found the positive of that. So we've actually found this angle in here as pi on 3. And we want to know this angle and all the way around to the other green one. So this is 2 pi minus theta, and this one is pi plus theta, Notice that we've got this interval here, negative pi to pi.
I don't know.
So if we start at 0 here and we go over to pi here, are there any solutions?
No.
No. So there's only solutions from negative pi, which would be over here, to 0. There's two. These two.
That's somewhat, well, it doesn't really matter because you can still find the positive pi over 3 and still go around and you still get the other thing.
Not quite, because they'll be, if you're going the anti-clockwise direction,
Yeah.
there'll be those angles, but you actually want the clockwise direction, like back around the circle. So it's not this one and this one. It's actually 0 take away pi on 3 and negative pi plus pi on 3. Right, so let's just deal with these guys here. So we're going to find those two angles. So that's negative 3 pi on 3 plus pi on 3.
Sure.
And so that equals negative 3 plus 1 is negative 2. So you get negative 2 pi on 3. So we've also got 0 take 3 pi, which is obviously just pi on 3. Negative pi on 3. Sorry. Because it was negative pi, and I want to have common denominator so I can add them. So I made it negative 3 pi on 3. Yeah.
So that's the bigger. Instead of that, yeah, then that way. It's going the other way.
So we're going from here around to there and here around to here.
Oh, so those are
Yeah, so the little one would be negative pi on 3. And then the big one would be negative 2 pi on 3.
Oh, yes.
I'm just going to wait.
Oh, yes.
Yeah.
Is it just me, or is it just the circle's not important?
Yeah.
No, it's
Because I'm
not.
looking at it, I'm
Yeah.
thinking it'd be that's why, you know.
Right, we're going to start this one again because it's going around in circles.
Everything has to do with
No draw Don't Take 7 for you.
Right, let's do this a different way. So usually we've got sine x equals negative root 3 on 2. This time we've got, instead of an x, we've got 2 theta. So what we're going to say is let x equal 2 theta. And because that angle is being multiplied by 2 theta, we're going to multiply our interval by 2 as well. So x is an element of negative 2 pi to 2 pi. Okay? Yep. Yep. Okay, great. So we're going to work it as if it said sine x equals negative root 3 on 2. Okay, so we work out the positive value first and then we just use symmetry. So we're going to work out x equals inverse sine of root 3 on 2. We already worked out that before. It was pi on 3. Everyone following?
this could be the highest number of the one time I put
Okay, so we've done root 3 on 2, and that was pi on 3. But because it's negative, we want to work out these two down here. So we want to know this one and this one. Right, so going from 0 to negative 2 pi, we're going around this way, and there's only two solutions. It's here and it's here. And it's negative pi on 3 and negative pi plus pi on 3. Yes.
Does that mean it's asking for the angle after one full circle and then the negative pi over 3? Is that what it's asking for?
Sorry, say it again.
Let me just draw it with my finger.
Solutions so far are negative pi plus pi on 3, which equals negative 2 pi on 3. And negative pi on 3.
So that's the answer?
Those are so far the two answers that we've worked out, because we've only done half of the interval. So we've only done this half of the interval here. No. Right, now we're going to do the other half of the interval from 0 to 2 pi. So that's from 0 here, anti-clockwise, the normal way, around to 2 pi. So we've got this bit here, we've got this angle here, and we've got this angle there.
Minus.
So it'd be pi
minus 2.
plus pi on 3.
Yeah.
And we've got 2 pi minus pi on 3. Right, those are our other two solutions. So we've also got pi plus pi on 3, which equals 4 pi on 3. And we've got 2 pi minus pi on 3, which equals 6 pi on 3. Take the pi on 3, so it's 5 pi on 3. So far we've got this one, we've got this one, we've got this one, and we've got that one. However,
Where did you get the 2 pi, negative 2 pi and 2 pi? Did you change that just to make it more example?
Negative where?
No, from the start, the domain.
Because we say we're going to let x equals 2 theta, because it's been kind of times by 2, essentially. You need to times your domain by 2.
Okay, so what happened with the other that we worked out by not timesing the domain by 2?
We were going to do it like later on, but it made more sense to do it this way. So
I told you that's what the answer is. I probably did it wrong.
right. So there's only one more step, and it's super easy. Because these are all our values for x, not 2 theta, we need to divide by 2. No?
Okay.
Because before we like times everything by 2, so now we need to divide
What
by
if you didn't
2.
times everything by 2?
Then it would work. So we tried to do it at the start, but
Yeah, so with the two values that we got at the very start, without timesing the domain by 2,
yeah.
how did we get the other two values for positive?
Yeah.
Essentially you have to go like double the distance around the circle in both directions.
Okay.
In both positive and negative.
Yeah. Right, so we need to, divide each.
Can we just times the bottom by 2?
Yes, you can. So that would give us, we just times the denominator by 2. So we've got negative 2 pi on 6. We've got negative, pi on 6. We've got 4 pi on 6. And we've got 5 pi on 6.
Can we simplify that?
You can simplify
We
those.
have to.
You should.
So it'll be like negative pi.
Yep.
That'll say
That one says Sam.
2 pi as well.
Yep. Yep. So we can go to negative pi on 3, negative pi on 6, 2 pi on 3, and 5 pi on 6. So that's our final solution.
That would be.
Oh, yeah.
Yeah.
See, a question like that should be worth like at least 25 marks.
25 marks.
Yeah, you get it wrong and then
Yeah.
Well, you